Learning Outcome 8.1. Convert equations describing amplitude modulation and filtering steps into block diagrams. We've used many mathematical elements in our equations in order to achieve a goal, and quite often we've drawn them in block diagrams. I want to take this and formalize this because starting in this chapter we're going to be using a lot of block diagrams, and I want to make sure that you can convert an equation into a block diagram, and likewise convert a block diagram into an equation. The mathematical elements on which we're going to focus are addition, convolution, multiplication, and gain. And we're going to look at them in the order of convolution, multiplication, addition, then gain. Convolution. You've had this since Chapter 2, and you saw starting in Chapter 2 that we would draw this as having our input signal going through a rectangular box, which represents our impulse response, and out comes our output signal. And y of t is going to be x of t convolved h of t. Now on each of these wires, in addition to a time signal, there is a frequency signal. They're not two separate things, even though you have to go through a specific operation in order to convert from time into frequency. They both exist at the same time. It's like taking a complex number, which you can represent in rectangular form or in polar form. Both of them exist at the same time. It just depends on how you look at it. As you've seen since early in this course, we alternate how we look at things depending on how it makes things easier to work with. H of t likewise has a frequency representation, and y of t has a frequency representation. And we can calculate everything in the frequency domain as well as in the time domain. But even though we've switched from convolution to multiplication, we continue to represent things in terms of the time domain operation, which here is convolution. Multiplication. You saw this in Chapter 7 with sampling. Take a signal x of t, multiply it by a signal p of t to get an output signal, here called xp of t. Likewise, everything has a frequency domain representation, and those operations exist in the frequency domain, even though the diagram is drawn for the time domain. Addition. Take two signals, x1 and x2, add them to create our signal y of t. In the frequency domain, it's very similar. As to how we arrange our elements depends on how important things are relative to each other. When they're drawn like this, there's kind of an implication that x1 is more important than x2. Or it could simply be that there was no room to draw x2 anyplace else. If we really want to show that they're equal in importance, we quite often could draw them in this configuration. It's totally equivalent, including the frequency representation. Gain is just multiplication by a constant. K is a constant, not a function of t, not a function of omega. And we draw it in a triangle. And likewise for this, there's also every signal has a frequency representation. So let's try working with these. If I say y of t is x1 of t convolved h of t plus x2 of t times c of t, how would we draw the block diagram? Pause the video, try drawing it out. Let's start with this first part. That's our convolution block. The second part is the multiplication operation. Then we have addition. There you go. It's important that you look at the order of operations, just like you did in elementary school, when you learned that multiplication has priority over addition and exponentiation has priority over multiplication. When you're drawing the block diagrams, you need to look and see which operation takes priority. Here's another example. Again, please pause the video and draw this out on paper. Start with this first block, multiplication. Second term is also multiplication. They're combined through addition. And all of this is followed by convolution. Third example, similar to the previous one. Again, please pause the video. Try to draw this on your paper. First term, multiplication. Second term is also multiplication. They're combined through addition. Then there's a gain.